Mr. Harish Kumar. This session is being taken by the keynote speaker, Harish Kumar Pamnani. And firstly, let me brief out about his achievements. Harish Kumar Pamnani, sir, he is from Poornima University at present. He has completed his MSc CS. After that, he did MCA, and presently he is pursuing PhD in computer science. He has 15 plus years of experience in technical training and development. He has worked with iNurture Education Solution Private Limited as a vertical lead of programming. Then he switched over to White Hat Junior as a curriculum manager, data science, and presently he's working as a coordinator of machine at Poornima University. He completed 7 global certifications from Microsoft, as well as he was an evaluator of Stackathon 21 for the final round. His core work is in data science, especially he is dealing with NLP, recommendation systems, Python, R, Java, C++, and C programming. In web programming, he has good hands-on on Ruby on Rails, PHP, and ASP.NET. As a database developer, he can easily handle RDBMS and NoSQL database, that is MongoDB. So here is a brief introduction of our keynote speaker of today. And I would now call upon the speaker to just take up the session. Harish sir, please.
Thank you, Anuradha ma'am, and good morning, all dignitaries and participants here. So we are starting our session. I am sharing my screen. Okay, so today we are going to learn that what is the linear algebra and why we require this in for the machine learning. What are the benefits to use the NumPy and what are the uses of the SciPy, or why should we use the SciPy over the NumPy? So at the first, so what are the use cases or the linear algebra, or why we use linear algebra for machine learning? So we everyone knows that if we want to learn the machine learning, it means we have to learn the mathematics, because the all the machine learning models are based on some mathematics. So we say that machine learning has a strong connection with the mathematics. So everyone who wish to make his career or want to learn machine learning has to good with the uh, mathematics, and we say the linear algebra. So we say that each machine learning algorithm based on the concept of the mathematics, and with the help of mathematics, we can choose the correct algorithm by considering the training times, complexity, and the number of features. Because we know that there are number of machine learning models are available. So we have to understand that which model is good for our data and our requirement. But for that, we have to understand that which or what mathematics is working behind that algorithm. So we say the linear algebra is the essential part of the mathematics, define the study of vector, matrices, planes, mapping, and the line required for the linear transformation. So before, without learning the linear algebra or the mathematics, we cannot switch over to the machine learning models.
So you're not audible.
Okay, please. I was muted. I'm repeating again. I think, see, so I said that's a machine. If we want to make our career in machine learning, we have to learn the mathematics. Without the basic understanding of the mathematics, we cannot move towards the machine learning, because we know that there are many algorithms are available for machine learning. There are the three types of machine learning we have. That's supervised, unsupervised, and the reinforcement learning. And in category of the supervised machine learning, again we have the regression and the classification. And the classification and regression, again we have the number of models are available. So before moving towards machine learning, we have to understand what mathematics is working behind that models or that algorithms. So we machine learning has a strong connection with the mathematics. So we say So each machine learning based on the concept of mathematics. So this is the basic unit of the machine learning. And linear algebra is the essential field of the mathematics which define the study of the vectors, matrices, planes, mapping, and the line required for the linear transformation. So we say that the linear algebra is the mathematical foundation, solves the problem of the represented data as well as the computation and the machine learning model. So we have to learn about the arrays, vectors, matrices, and the tensors. Okay, so just see this, check this diagram. In machine learning, let's suppose that we have this data available with us, like the height, age, and weight of some students of a class. So we need to convert this data into machine learning into in that format, so that our machine learning model can understand so what's the meaning of this data. So because we cannot directly represent this data to the machine learning model, likewise a supervised or unsupervised. So we have to convert this model. So these are the so these are the machine learning models we have for the linear regression for the linear algebra, like the logistic regression, linear regression, decision trees, SPM, SVD, and the clustering and the component analysis. So whenever we want to predict anything, whenever suppose there are two variables, one is the dependent variables and another one is the independent variables. Okay, so I'm taking one example. So let's suppose there is a shopkeeper who sells ice creams. Per day, his sales of ice cream is the sometimes 25, 36, 89, and some on. If suppose he wants that how many ice cream he have to order to his vendors, so that there must not be wastage of the ice cream, and the seller and his buyer will acquire at least one ice cream. So actually we want to prepare a model which which should be based on the temperature of that day and the number of the ice cream. So if temperature is the high, so he will order more number of ice cream. If temperature is low, then he will order the less number of the ice creams. So if he want that there must not be some wastage of the ice cream, so we have to prepare a linear regression model which depend on the temperature as well as the number of the ice cream. So we consider as a linear regression. So it's a statistical model which show the linear relationship between the response and the explanatory variable. We say it's a dependent or the independent variable. So we need to write that equation in the matrix formats. Again, there is a PCA, like the principal component analysis. So what does it mean? So let's suppose there are the number of features available for a data set. Might be possible that each feature is not good for our machine learning model, or it's not required for the machine learning model. So we need to filter, or we need to get only those features which are much required for our model. So we say it's a principal component analysis. It's a method. It's a mechanism to reduce dimension reduction technique. For this, all we require linear algebra for the optimization as well as single value decompositions. So I'm coming towards. So these are the basic things we require for machine learning model, like the scalars and vector. So any single number like the 5 minus 2.767 whatsoever we have, it's called by the scalar values. And the collection of the numbers like by 3, 1, 4, and so on is called by the vector values. And any value which is divided into row and the columns, or we have the arrangement of values in the row and columns, it's called by the matrices. Again, transposition. So these are the few things we have to learn for the machine learnings, or these are the basic components of the linear algebra. So before moving towards the SciPy, we have to understand what is the use case of the NumPy, why we require it. Before understanding the NumPy's arrays, we must understand the why we require the NumPy. Actually, NumPy is a library of the Python. So we can prepare our arrays by using the NumPy. But the thing is that we already have concept of the list. We have the concept of the list in the Python. So why actually we require the NumPy? So let's suppose we want to create a collection of the values, different types of values. We can use the list. So why should we prefer the NumPy over the list? So I'm presenting few examples that why we required it. So actually NumPy is purely written in the C programming. So we consider that the NumPy has the more fast execution time or the less execution time for our program. So it is a more optimized compared to the list. So whenever we have the large number of the values, so instead of using the list, we should go for the NumPys. So
Excuse me, sir.
yeah, please, sir.
Sir, there are some participants who are not familiar about Jupyter Notebook. So if you can a little bit expand about what is Jupyter Notebook and how we can create the file and how we can open and the basic about Jupyter Notebook. So this will be very informative to all the participants who are very beginner and unknown participant.
Sure, sir. Just give me a few
Yes, sir.
minutes. Yeah, please.
Yes,
Thank you,
yes.
sir.
Thank you, sir.
Thank you, sir. Okay, so participants, what's the meaning of the Jupyter here? See, let's suppose that if we want to create our Python program, so we have the few things here. So my screen is shared here. So create a Python program. We have whenever we install our Python. So by default, we have the interface of the Python. We call it the IDLE. So we can prepare our program in IDLE. You can see my screen here. I opened IDLE. So whenever we install Python, we always have this kind of interface, which is by default for the Python users. So whenever we want to write our program, we can write our program in the Python. Likewise, in Python ideally, likewise hello. Okay, so this is thing here. The problem with this ideally is this: if we want to create a big program or a program which has the hello, I'm audible, sir. So let's suppose we want to create a big program which has the good number of the lines. So we cannot use the ideally. So one thing is that we can create a file. Just go and create a new file. So we can write our program in new file. You have to save your program in this initial. This is untitled. We have to save our file here. So this is the basic thing which we get whenever we install Python. So let's suppose that's my program is the first. Okay, so I can write my program here in this file. This is, let's suppose this is my code here. Okay, just save this one. If you want to execute this program, just go to the run and press run module or press F5, or you will get your output here. This is the MTTF workshops kind of, okay. But the problem is that if we have big number of files or the code is a very the line of the code is a very big, so we cannot write our complete program in ideally because this is not a user friendly environment. So instead of using this ideally, we always prefer some another idealies, like we say the PyCharm. Someone use the Google Colab, and someone is the for Jupyter. So Jupyter is a application which we use for the Python whenever we want to write the Python program, or we say it's a provide an ID. It provided an interface. Okay, although we can use the Google Colab also, but whenever if you want to use the Google Colab, it means we have to connect with the internet. And if in a area if internet is not good enough, so you want to be you won't able to create your own programs on Google Colab. So this is the reason we generally we prefer. So generally we prefer Jupyter Notebook. So see how to install the Jupyter Notebook. Just check, go to your command prompt, CMD, and right here, pip. Pip is a command whenever you want to install a library through Python, the library which is not available in Python, and we require it. So we use a command, pip command. So pip is a default command. Whenever we install Python, it automatically install in our system. So in my case, Jupyter is already installed. So what we need to do, we have to write a pip install Jupyter, Jupyter, Jupyter. Okay, just press enter, and don't forget to connect your computer with the internet. So by using this command, it will install Jupyter on your machine. It provides the same interface which we get as on the Google Colab to with the internet whenever we're writing our programs. So once it is installed, it is installed, we have to execute our Jupyter notebook. I'm writing your command in your chat box so that you can note down this. So pip install Jupyter. By using this command, you can install your Jupyter. And after installing, if you want to launch your Jupyter, you have to write Jupyter, Jupyter, Jupyter notebook. Check your chat box. I'm writing there, Jupyter notebook. So it will launch this kind of interface. See, this one. Get this kind of interface. So if we want to create our own file, so just press on the new notebook. It will create a blank notebook for you. If you people are working with me, so you can ask me question if you are facing any problem. So you will get this kind of interface. The advantage of Jupyter is that you can execute your code line by line here, like print hello, press control, press enter, you will get your answer here. If you want to add one more cell here, just press on the plus inside a cell. By using this, you can create more and more cell as number of cells you required here. So like A equal to 10, B equals to 20, and C equals to A plus B, and print C. This is a very basic program, 30. So we can execute our code line by line, as well as for the fresher person. Let's suppose if I want to tell you that what is the use of this cell here. So I'm adding one more cell from this cell instead of cell above. I can put a note for my user. So we have one thing here code here, change by it as a markdown. So that means we want to need to compile this cell, or we do not require to compile this cell. And likewise, you can write your HTML code here like H1. This is addition of two numbers using Jupyter. Okay, so it means it will create a two-way. Create a communication way with your user who using your Jupyter notebook. So you can create your own notebook here. So this is the we say Jupyter notebook. So in Python we have two data structure. One data structure is called by the list. So what is the list here? So list means, see, I'm creating. So we say list is a collection of different types of values. Different types of values. Okay. So let's suppose if I want to create a list, so we have to write like x equals to square bracket like 1 2 3 4 5 6 and so on, this list. And we can just print this as x. We'll get our output 1 2 3 4 5 6. So this is something like, this is like array of C programming, C, C++ and Java, something like, but something like okay, but it is heterogeneous collection of values. It means in C, C++, Java, if you are good with the C, C++ Java, you can understand that's In C and C++, we can create a similar types of values, but in list we can we can insert a different types of value. That means string, float, real, and so on. So let's suppose if I want to add some string value, I can put here A, B. If we have some real values, we can work with the real values also. So this is the list. Yeah. So this is the way how to create an array of values in Python, and how to create a Jupyter notebook. If anyone has any issue, you can raise your hand. So now we are moving towards the NumPy array.
Yeah, actually, sir, there is also small information about all the participant. You are permission to unmute your mic whenever required, or you have any question. So immediately you can ask from the speaker. Thank you.
Thank you, sir. So now this is the list. So we say the list is a collection of the different types of values, or it's a heterogeneous collection of values. So we are learning about the NumPy. So now question rise, if we want to create an array, we can use list. So why should we use the NumPy? Again, NumPy, what is the NumPy? So NumPy is a library of Python. So NumPy is a library of Python. Library of Python. So whenever we want to create, so we say that whenever we want to do some mathematical operation on some values, so instead of using the list, we prefer the NumPy. So if you want to install the NumPy, so again, what you have to do, just go to your command prompt, or you have to write the pip install NumPy. Pip install NumPy. If this is already installed, it will it will show that the requirement is already satisfied. But see, in my case, it's saying the requirement already satisfied. It means this is already installed for my system. But you need not to move.
Excuse me.
Yeah, man, please.
Excuse me, sir.
Yeah,
Does
please.
this command pip install NumPy requires internet connection?
Yes, it requires internet connection. Whenever you want to install any library which is not available by default by the
Hello.
Python, yes, yes, you have to connect with the internet. Any library which
Yeah.
is not by default available with the Python, if you want to install that library, you have to connect with the internet. So instead of using the command prompt, if you want to
Thanks, sir.
execute, yeah, thank you. So if you want to execute your command on over the by the on the Jupyter notebook, you have to write like exclamation symbol pip install numpy, or we say SciPy. SciPy is another one library, SciPy. So you do not require to move to on the command prompt. Just write your command on Jupyter notebook by using the exclamation symbol pip install SciPy. So just press your control plus enter. This star is showing that your command is running here. If you are getting this output, likewise you seeing on my screen, requirement already satisfied. So it means this library is already available on my system. So this we are not able to again install this file. So pip install SciPy. This is the thing here. If you are seeing this number here for 4 years, you can see this here. The in the square bracket you are saying the 1, 2, 4. So what does it means? It means that how many times this cell has been done by me, executed by me. Okay, so NumPy. Again, we are moving towards NumPy. So we are saying if we want to create a collection of the values, so we have two options. One is by using the list, which is the core component of the Python, and second is the NumPy. So NumPy is a library for which we use, which is used for the mathematical calculation. So if we want to, if we have the large number of the values, so we prefer to choose NumPy instead of the list, because NumPy is purely written in the C programming, in the C concept. So its speed or execution speed is the more fast compared to the list. So we are moving towards another one more example. See. So we are explaining the why we required or why we should be moved towards the NumPy instead of the list. So I'm giving one example here. Okay, see. So just check this one. After installing the library, if you want to use its functionality on your Jupyter, so we have to write the command import the name of the library, which is the NumPy, as NP. NP is the alias name for the NumPy. So it means instead of using the NumPy dot method name, NumPy dot function name, we can use NP dot function name. So NP is just a alias name for the another name of the NumPy library. You can use any name here. So let's suppose if I want to use the MTTF instead of NP, I can use it. So as keyword is used whenever we want to declare alias variable. So import NumPy as MTTF, or we can use NP here. Okay, so our objective of this program is that we want to find that why should we use NumPy array instead of list. So see, we are creating two array. One is by using the Python list, and second is by using the NP, or we say the NumPy. So in this line, first line, NP dot range one something. So what this means? So range is a method used to execute iteration till the range, till the given range. So if I write here, so let's suppose if I write here range x equals to range 10. It means I want to create an array of the 10 number start from the 0. So x will be an array of the 10 number. So 10 number will be 0 to 9. Okay. So this is the user range here. So we are creating an array np dot arrange. So arrange is a method in NumPy array actually. Okay. Range is for the list. Range is used for the list here, and for the NumPy we have another method arrange here. So np dot arrange, by using this we are creating an array, and by using the range we are creating a Python list. Okay, so again I'm repeating that we are comparing that why should we use the np array instead of the list if we have large number of the values. Okay, so we are finding the time taken by these two programs here. So print time taken by the list, we are getting this one like percent time. So what is the meaning of percent time here? Percent time is called by sometime we call this a percent time is a magic method actually. So what is the magic method? So instead of adding the library on the top, let's suppose if you are not want to use the percent time here, so another way to using the time library, we have to import time. So instead of importing time, we can write the percent time if we use some inline execution of a library. So percent time in range 10, we are executing item into 3 for item in the pie list and so on. We are doing the same task. We are multiplying our number of the values by we are multiplying our number of values multiplied by 3. See, so if you want to execute this execute this cell, press Control plus Enter. So you can check. See, so time taken by the list is the 369 milliseconds. On the other hand, time taken by the NumPy array is the 5.98 milliseconds. So you can compare that the NumPy array is taking the very less amount of time compared to the list. This is the reason why we always learn or always like to work with the NumPy array if we have the big number of values. So we are taking one more example here. See. So in this program, we are importing time. We are defining a method like the list version. Again, we are creating two array. One is the x and second is the y. And we are adding the addition of the two arrays x and y and storing that addition into third list z. So actually we have three lists. One is the X list, second is the Y list, third is the Z list. We are adding X and Y list and storing its addition in third list Z. Again, our intention is to find the time which is taken by this list. So if we execute this cell, we have to wait because this star is showing that it is taking some time. So this is time in the milliseconds, 3.749. If we execute the same program, but creating the array, sorry, np.arange. See, earlier we were using the range. Now we are using the np.arange. The range is the similar as we were using with the list. But if we execute this program, you can see the output. It is taking the 0.11 milliseconds, but the same task, if you done with the list, it was taking 3.749. So this is the reason we are optimizing our code by using the NumPy array. So this is always advisable that if you want to work with data science, if you want to be data scientist, so you should work with the NumPy. I hope this is clear now. So in this notebook, this is mentioned that what is the NumPy array? I already mentioned you the NumPy array is a numerical Python. So the full form is a NumPy is a numerical Python. It's an open source library for the scientific computing in the Python. Okay, so if you want to create a high performance matrices, arrays, or any linear algebra libraries, linear algebra mathematics, so we should go for the NumPy here. Okay. So why should we NumPy? This is already clear that why we use the NumPy, because this is already clear that if you are using the NumPy array, it means the time taken by your algorithm will be quite smaller compared to the list, because this is the completely written in the C programming, or we say that's the reason this is taking the lesser amount of time. Yeah, I will share it. So what is the Python NumPy array? We say NumPy array is a grid of the values, or there is a collection of the values. Okay. So how to install NumPy? We already learned how to install this line. So we can write the pip install NumPy. If you want to check the version, then just check the np version. You will get the which version of the NumPy you are using. But this is not much important. Just learn how to create or how to use the NumPy. See. So these are the some basics of the NumPy. If you want to create an array, then command is the np.array, like 1, 2, 3. It will create a 1D array. 1D array means one dimensional array. And if you want to create a two-dimensional array, then use the np.array and the 1, 2, 3, and 4, 5, 6. Definitely we will execute this code also. But before executing that, we have to understand that's why we are using that methods. So np.array 1, 2, 3 and np.array 1, 2, 3, 4, 5, 6. So I hope now you can understand that's why we were using np.arrange instead of the array. See, in our code, we have used np.range. np.range. np.arrange. This so instead of using np.array, we were using np.arrange. So why we are using that? Because whenever we are using the np.array, the number of the values which we want to input in array, we have to mention that values. But if we want to create a big array, a random array, okay, so we can use the arrange method. So it works like that: start, stop, and step. So step means how many number of by the values you want to jump. By default, it start with the 0. Stop, that means how many times you want to iterate that array. Step means how many times on the you want to jump it. So these are the some methods. These are given in array. We will learn one by one. We will execute these methods one by one, and definitely we will learn. So what is the meaning of this one? Okay, so these are the summarized sheet where you will get the all the methods or the most of the methods of the NumPy array. But for more the more information, definitely you should use the NP documentation. So, okay, so this is the Visa NumPy array. So, okay, if you want to execute with me, you can do it. So at first, we are using the NumPy library. So now I understand. I hope that you have learned that's why we are using the NP here. So instead of NP, you can use any other name. So just run this one. Import NumPy. We are creating one list here, like this one. Okay. So this is the list here. So how to find that this is a Python list or this is a NumPy array list? How can we check this one? That my list is an array. Definitely this is an array. But if I want to check whether this belongs to the Python list or this is a NumPy list, so use a method like type my list here. So type is a inbuilt function of the Python which is used to find the what is the data type of the variable. So type my list is showing the output, we are showing the list. It means this is a list, but this is not a NumPy array. This is not NumPy array. So in my next style, if we want to convert this NumPy, if we want to convert this Python list into the NumPy array, so we use another method like the np.array. I hope and I think that so you everyone now understands why we are converting this Python list into the NumPy array, because the execution speed of the NumPy array is the quite high, or the performance of the NumPy array is the more than that Python list. So this is the reason we are converting this Python list into the NumPy array. Okay, so we have method np.array. In our previous notebook, we learned that's what is the meaning of the np array. If you forget, I am again telling you what's the NumPy array here. See, the first method of this was the np.array, like this one. np.array 1 2 3 1D array. So we are creating our Python array. So np.array mylist, by using this method, we can convert our Python list into the NumPy array. Just execute this one. We will get this output. But if we check this by using the type method again, the type is a method. See, earlier we were getting the list. By now we are using the numpy.nd array. So numpy.nd array will denote that the data type which we are using here is a NumPy array instead of the list. So by using this np.array, we are converting our Python list into the NumPy array. Okay, so the another thing, if we instead of using the Python list, if we want to create if we want to create a NumPy array by using directly from our values, so this is the way we can create it. So my list one and np.array. Okay, so this is the way how we create a method. Next, we see what we are doing here. So we can create array from a tuple. So what is the meaning of tuple here? See, in Python, if you are not familiar with the Python, I am telling you that in Python we have the different type of data structure. So we can categorize this data structure in two categories. One is the immutable type. Second is the mutable types. So what is the mutable or immutable types here? So mutable types are the data structure, are those data structure, the values in which we can change the values. We call it say mutable types, and second is the immutable types. Immutable means once we create data structure, we cannot change that values, called by the immutable type. So just give me 1 minute. I'm writing here so that you can understand more in a better way. So we have two ways here. One is the mutable type and second is the immutable type. Mutable, it means value can be changed. can be changed whenever we required. Second is the immutable type. It means values can't be changed. Values can't be changed. Okay. So then the example of the mutables are that examples are the list and dictionaries and so on. Can't be changed. We said numbers. Numbers are kind of the immutable types. And second is tuple. Tuple. So these are the immutable types here. Okay. So tuples are represented by parentheses, and lists are represented by square bracket. So these are basic things here. Okay. So now we are creating our NumPy array by using the tuple here. So see, so we are reading range 1, 5 and list 2. So this is written here. We can also create a NumPy array from a tuple. So tuple means it's a data structure. Once we create a tuple, we cannot change its value. Okay, C1. So if you want to create one more array like b equal to np array, now we are creating a two-dimensional array, 2D array. So like 9.0, 8.0, 7.0, and so on, and print b. So we will get this answer here, 987, 657. Again, this is a NumPy array. The same we can use, same we can do by using the list. If you want to create a 2D array, we can also use the list. But all now, I hope that again we now we understand that's why we are not using the list here. This is a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. We are creating an matrix here. See. So if we check this one, I'm committing here. If we again check the type here, my matrix. Again, the type of the my matrix is a list here. Okay. By using the np.array my matrix, we are converting this matrix into the NumPy array like 1, 2, 3, 4, 5. We are getting this array. Array symbol shows that is a NumPy array. Okay. By using the nd method, we can check the what's the dimension of our array. A.ndim stands for the dimensions of the A here. Okay, so why it's A here? Because sometimes we miss the A. Execute this one. So A.ndim, we are getting one. This is a one-dimensional array. If we want to get to that, it's a multi-dimension, so we can use b.shape here. Number of values, item size. Okay. If you want to find the total number of the bytes, so we use method n bytes. Number of element a.size. A.size stands for the number of the values 3. So 3 stands for we have the 3 values here in A array. In A array we have the 1, 2, 3. These are the some basic methods. In the same manner, if you want to create an array for the Boolean values, we can use a true, false, and so on. See, execute this one. Check your c.size or shape. C.shape will say that it's a 2 by 2 array. In this program, what we are doing here, we are creating an array 1, 2, 3, create a 1D array. Then we are printing value of the A. The value of this is a 1, 2, 3. Again, if you write the print type A, it means it will share or it will denote that what is the data structure of the A variable here. So if you are getting the class numpy.nd array, we already done this. If you are using the print A.shape, it will say it's a 3 values 3 by 1. If you want, you can print A of 0, A of 1, B of 2. So what's the meaning of the A of 0, A of 1 and A of 2 here? See, Whenever we create a collection of the values, the first value always store on the zeroth location. So we are writing the a of 0 here. The a of 0 show the first value of the array. It's a 1 here. A of 1, it means the value which is stored on the first number index. It's a 2 and the 3. So we'll get the 1, 2 and 3. If you write the a of 0 equal to 5, it means we instead of that means we want to replace the value which is stored on the 0 location with the 5. Okay, so earlier on the 0th location there was written the 1. Now if we are writing the a of 0 equal to 5, it means instead of the in place of the 1 we want to write there 5. So the output I will get the 5, 2 and 3 now. So I will get the answer 5 to 3 here. In the same manner, we are creating one two-dimensional array. Likewise, 1, 2, 3, and 4, 5, 6. Print B shape. I will get the 2, 3. It's a 2 rows and number of columns are a 3. So I will get a 2 or 3. Okay. Because this is two-dimensional array, if we want to print the values, we have to mention the row number and the column number. So we have to write the 0, 0. So 0th row and the 0th column, values of the 0th row and the 0th column, 0th row and the first column, and the first and 0, so on. So by using this, we are getting this output 1, 2, 3, 4 here. Just check this one. See, so these are the array data types here. So we have the bool, object, number, flexible. So we have the number of data types available with the NumPy array. If we want to create an array by using the NumPy, this is the almost complete chart which we can use. So generally we work with the integral values or the real values, but these are the number values which can be used. Okay. So if we want to create a NumPy array with the 32 types, so what is the meaning of in 32 type? It means it will allocate 4 bytes of memory. It works on the memory system in 32, in 64. So if you are familiar with the programming language like C, C++, and Java, you will understand what's the meaning of the 32 here in 32 here. So it's a like data type in 32 here again. Okay. So why we are getting as a float 64 here? Because in my array, this is written 9.0, 8.0, 7.0. It means some real values are written there. This is the reason it is creating float type value. One thing that's although not belongs to this lecture, but this is good to inform you that Python is a kind of the true object-oriented programming language. It's follow the more OOPS concept than the Java programming language, because in Java, if you are using the Java, C, C++, then in that programming language, we always write the data types like int, float, and character. But in Python, the whatever value is assigned by the variable automatically create that type of data type. It means we need not to explicitly mention that the what types of value we want to store in our variable. Okay, the same manner, B is holding the values of the real values, so it automatically convert itself into float types values. So these are the very basic things which we need to understand if we are using for the NumPy array. See, again there are a method like random np.random.rand. By using this method, we can create any random numbers of the 3 numbers. Okay, 3 to 5 random numbers. Again, these are the few methods. Sometimes we require these numbers if we want to create some data set for our training programs. So these are the functions here. Functions of the NumPy array. So rand n means if we want to work on the normal distribution. So what is the normal distribution here? Normal distribution is a way to arrange the values or the distribution of the values. So we have the one normal distribution. So what is the meaning of the normal distribution here? It means it is making as a like bell curve type of values. So it's not uniform with the mean 0 and the variance 1. So if you are working with the data science or you want to be data science, definitely you will learn the what's the meaning of the normal distribution here. So if you want to create a values, we should follow the normal distribution pattern. So we can use trend n method here. Okay, and the same manner gradient. Okay, so it will create integer values between from 2 to 100, any values. If you run this program, anytime you can run execute this program, you will get a number between 2 to 100, a single number between 2 to 100. It's a random integer number. Okay. If you want to create a 2D array of the random size or the random number values, 3 by 3 array of the random number of values, so we use this method again. Okay. These are the functions for the NumPy array. We mostly we require this data whenever we want to create our own data sets. See, in this loop, what we are doing, we are using a zip method here. So what is the meaning of the zip here? Zip is a method which used to combine two or more list order dictionaries which having the same size. So I plus j for ij in the zip. Okay. So by using the zip method, we are creating a list here. I will share this notebook with you so you can execute these programs again. So because we have a short time here. So okay, so we have to execute random attributes here. Now execute this one. So we have few values like the 9, 4, 6, 6, 8, 1, 2, 2. If we want to find the maximum number from an NP array, we use the function max here. We will share. It will show return the largest value, main and argument means. Okay. So these are the another methods. So these are the another methods which is used to create an array. So let's suppose if we do not have if we do not have values for our array, initially we don't know that's what values we want to insert for an array. But if we intend to create an empty array, so we can use zeros method here. So see, by using this, we create an array of the size 5. The all values will be 0 here. Later on, we can change the values here. Likewise, you store the values in a variable. Yeah, we say that in the ARR variable. Okay, print ARR here. If you want to change this value, anytime you can change this one, like 12,0,0 So let's suppose initially do not have the what value you want to insert in array. But if you are sure that's what should be the size of that array, so you can create an array of the zero size. Zero values, not zero size, zero values. Later on, you can change this value. So initially we were having an array of the an array of values. The all values are having the zeros. Later on, we change the zeros value with the 12. So we are array 0, 0, and so on. Okay. In the same manner, if you want to create a 2D array, but you don't know that's of what values will be there, so you can create like np.zeros 2, 3. So this is very clear. It will create an array of 2 by 3. It means 2 rows and the 3 columns. Again, so 2D ARR, 2D ARR. We have 2D ARR. Print 2D ARR. I will get these values here. Okay. If you want to change these values, again, the same manner you can change it. Like 2D ARR 0, 1, mention the row and columns, you can change it. Okay. Likewise, the zeros method, we have another method once. So what it will do, it will create the values with 1. So np.13 means it will create an array of size 3. all the values will be 1 by default. Later on, if we want to change values, you can do it. So the same manner, like we are using the zeros. So once example equals to something like this one, like print once example one example one example. If you want to change the values, you can write example of 2 equals to 100 and print like this one. You can change here. Earlier, we were creating the array with the 3 values, all were having the 1. Later on, we changed the values and we changed the value of the second index here. Likewise, one example, 2 stands for the index number of the 2 equal to 100 and print one example. So it shows the 100 here. Okay. By 5, so we are creating one array of the with the 5. So if we create likewise, if I create a 10 here, so it's a creating an array of the 10 elements here, and all values is multiplying by the 5. So why it's a 5 multiplied by 5? Because by default, once create an array of the 1 means all values will the 1. So 1 multiplied by the 5, and the total size is the 10 here. So these are the another ways to create an array here. Like once 3 by 3 comma 3, it will create an array of size 3 by 3. Okay, the all values will be 1 here. On the same manner, you can create an ND array like 4 2 comma 2, 4 rows of total number of values as a 4, 2 rows and the 2 columns. So instead of 1 and zeros, if you intend to fill your array with any other number, so you can use full function here. So it means we will create an array. We will create an array of 2 by 2, and the all values will be 99. So instead of 99, let's suppose if I write 57, let's suppose any values here. So it will create an 2D array of the 57 and 57. Okay. So these are the methods to create arrays. Like NP array 1 2 3 and so on. Repeat R1. Again, you will get the same answer here. So these are the complete methods here. So if you want to create an identity matrix, you can write here like I function. For the more methods, you have to check the documentation for the NP. So you have to write here like NumPy documentation. NumPy documentation. It will share all the other things or all the other methods. See, these are the NumPy methods here. At first, check the version of your NumPy and click on that link. It will share the entire documentation for the NumPy. Okay, this is the one thing we created here. Now we are moving towards some advanced versions of the NumPy. See, so now we learned that how to create the NumPy array. Now we want to do some mathematical operation or a NumPy array. So how to do that? See, so we created a method like we created an array like np.array, and we are having some values like 0 1 2 3 4 5. So this is the way here 0 1 2 3 4 5. If we doing the plus 2 here, okay, so what I will get, it will add the 2 with the each value. Again, this is the advantage of the NumPy over the Python list. If you want to add the each value of array, or we want to multiply the each value of the array by 2 or with 2. Okay, so in list we have to iterate our list. Okay, but in Python, in NumPy we do not require this. Just write a plus 2, but it automatically add each value of the array with 2. That's the reason we are getting 2, 3, 4, 5, and so on, so on. Okay, the same we can write a minus 2, a into 2. But let's suppose if we're using the NumPy, instead of we were using the list. So the another method of the list. So suppose we were having a list like a lst equals to, and we were intent to do the same task. Okay, so we were need to iterate our loop like for I in range 3. These were the method by using this. And if I write the lst equals to lst of 0, or why to use lst again, like lst1 equal to lst of I plus 2, it means it will the add the 2 with the each number of the lst1. But instead of doing this iterative task, we can use the NumPy array here. If I write a plus a, it means again it will add the two matrices here, and we'll get the 0, 2, 4, and 6, 8, 10. It will add a plus a, 1 plus 1, 2, 2, 2 plus 4, 6, 8, and 10. This is another benefit. We can use it. Okay. So if we divide a number by 0, so a minus a, we are having 0. If we divide a number, it is showing a warning, but not by error. Okay. If we do the same thing with the NumPy, with the Python list, we will get an error. But in NumPy case, we will get an warning here, and we will get a value NaN. So what's the meaning of the NaN here? Not a number, because the first value of the array was the 0. We are getting the NaN here. We can add two arrays like this way. The first array was the A, and second was the B. Both are the having type, both are types of the NumPy array. So we can write the A plus B, and we will get the answer 1, 2, 3, and so on 5. These are the some mathematical functions, like the if you want to find the square root of a value of the array values, like so we can use the np.sqrt. So sqrt is a method which is inbuilt with the NumPy array. But let's suppose if you are not using the NumPy array and you are working with the core Python list, then you will need to import the math library, and the function of that was the math.sqrt. So, but if you're using NumPy array, you can write the np.sqrt here. You can find the exponential way, find the maximum of the array here. Okay. The same manner you can find the mean, mass, sine values. Sine stands for the sine, sec, cosec is a trigonometry values for the array. For the cos values, write cos A, sec, sine, sec, cosec. These are the trigonometry values. So NumPy is used for the numerical Python. We already mentioned. So if you want to work with the numerical operation with the Python values, so we use the NumPy here. Again, see. So now we have two array x and y, print x and print y. Okay, just check this. If I write print x and print y, I will get the value of the x array and the y array, and x and y array both are the numeric array. See, this is the x, so the best thing is that I can comment all the operation here, so we can learn line by line here. So now we have two arrays. One is the 1, 2, 3, 4. Second is 5, 6, 7, 8. So one is the x value of the x. Second is the value of the y. Okay. So if we want to find the sum, element by sum, so we can write x plus y like by this. Sum is the x plus y. See, 1 plus 5 is the 6 here, and 2 plus 6 is the 8 here, 3 plus 7 is the 10, and the 12, and so on. Okay, and the same thing we can get by using the add. You can check your answer here. Answer is the quite same, because either you can use the plus operator or you can use the add function. Okay, in the same manner you can subtract numbers by using the minus operator or by using the subtract method. You will get the answer same. Okay, so this is, I will share this sheet. You can execute this one, because due to shortage of time, this is not possible to execute all the cells here. I will share this sheet with you. This is another beautiful method of the NP array. See, if I write np.sum x, it means it will compute the sum of the all values. So 1, 2, 3, 4. So 1 plus 2 plus 3 plus 4. Okay, but let's suppose if we want to find the sum of only columns, so we can write the x is 0 and the x is 1. So this is the reason we get an answer of 4. 1 plus 3, 4. 2 plus 2 plus 4, 6. And 1, 2, 3, 7. So by using x's, we can get this answer. So if we want, if you have a 2D array and you want to find the sum of the numbers by the different ways, by the row wise and the column wise and the total number of sum, so you can use this method here. Next is the matrix multiplication. Again, by using multiplication, we can use another function like the matmul. By using this method, we can use the matrix multiplication of the matrix here. Okay, determinants, these are the another methods. I will share this sheet with you guys, so you can use it. Now, this is the all about the NumPy array. Now we are moving towards the SciPy. So SciPy is another library which is used for the scientific calculation in the Python. So it works over the NumPy array. So if we again you have a very large number of values and you want to intend some more scientific methods with your data set. So instead of using the NumPy array, you can use a SciPy array. So it is built on the NumPy extension and allow the user to manipulate user data with a wide range of the high level commands. Okay, SciPy is built on the NumPy. So if you import the SciPy, there is no need to import NumPy. So if you are using SciPy, that means NumPy is automatically installed on your imported on your machines. So what is this SciPy? We say it's over 100 functions for the mathematical operations such as the addition, subtraction, multiplication, division, and so on. Okay, there are the many functions which is used for the statistical analysis like the mean, median, hypothesis testing, pi test, t-test, t-test. There are many other values, many other statistical methods are available. A library of many functions for the linear algebra like matrix multiplication and inversions. If you want to optimize your code, so there are the many functions are given there like the Fourier analysis, Robinson method. Many methods are given there. Okay. So we say SciPy is built on the Atlas, LAPACK, and BLAS library. This is the reason it is providing very fast linear algebra capabilities. So again, if you want to optimize your code, so instead of using the Python list or the NumPy array, you can use the SciPy array, SciPy list. Okay. So what is the meaning of the BLAS, LAPACK, and Atlas? It's a basic linear algebra subprograms. LAPACK stands for the linear algebra packages, or Atlas means automatically tuned linear algebra software. So if you are importing your SciPy library, that means you are optimizing your code. Okay, so let's start with the SciPy. I'm sharing my sheet again here. Okay, SciPy. So if you want to install your SciPy, so you have to write pip install SciPy, SCIPY, SCIPY. So SciPy minus py, you can write minus py. It's a complete name of Python library here. Wait. It is showing the requirement already satisfied. That means in my system, SciPy is already installed, so I'm not able to again install. But if you want to install, you have to write pip install SciPy, and you have to connect with internet whenever you installing any library here. Okay, so these are the some functions of the SciPy here. So at first, I want to tell you that's how to get the functionalities of the SciPy here. So see, at first you have to write the import SciPy. This is one way, or second way is the from SciPy import star. It means you want to install, or you want to get everything from the SciPy. So from SciPy import star, and help will show that's which thing you want to get from SciPy. So let's suppose if I don't know how many functions are there, so just write there help bracket. So it will open an interactive way for SciPy. So just write here that which function you want to know about the SciPy. For example, multiplication or clusters. Okay, either cluster or like addition. Or if you want to quit it, just write it quit. If you already aware about that's what you want from the SciPy, so instead of writing just help, just write help cluster. So it will tell you that's what is the meaning of the cluster library here. Is a cluster is a sub package of the SciPy cluster. Okay, it will tell you the what's the meaning of the SciPy cluster here, and how many functions are there, and what contents are in that package. Okay, so if you want to get help from the SciPy, just write help function here. Okay, so these are the few functions about the SciPy, like exponential and trigonometric functions. So like exponential of 3, exponential of 2, and sine and the cos functions here. Just execute this one, you will get this answer. 1008. 8 means exponential. My function was the exponential of 3 2. That means to the power 3 kind of. So I'm getting answer 8 here. So see. So these are the few methods here which is used for the integrate or for the coding the values here. Again, these are some mathematical because we are working on the scientific Python. These are our objective of today's session. So these are the all methods which are use only for the scientific methods here. So again, if you want to work with the machine learning SciPy, you're supposed to be good with the mathematical side. You have to understand what's the meaning of the squared here, and how to find the multiplication of the matrices here. What is the meaning of the dot matrix, and the how to find the roots of the polynomial. So NumPy is capable to finding the roots for the polynomial and the linear equation, but it cannot find the roots for the non-linear equation. So this is the benefits if we are using the SciPy. For example, if we are having the x plus cos x function, so we can use that optimize function here. So SciPy optimize import root. By using this, you can find x plus value of the x plus cos x. So this is my equation here, x plus cos x. Again, this is a mathematical function, linear algebra method function. So you have to understand what is the meaning of that function so that you can apply that function on your code. Again, so these are some optimization algorithm. If you want to, with the neural network, if you want to work with a deep learning method and you want to optimize your code, so these are there are many other methods. For example, there is a BFGS. So it's a Newton approximate the Broyden, Fletcher, Goldfrapp, and Shiner algorithm. Okay, so what it will do, it will execute your code with the limited
Hello.
amount of memory. Yeah.
Hello.
Yeah.
Dr. Sumalata ma'am, your mic is on. Kindly mute yourself, please. Thank you. Kiran ma'am also.
Thank you. So if you're working a big amount of data, it's always a problem for a beginner or a fresher or data scientist how to work with the large amount of data on a small memory. So we need to optimize our code. So there are the many other methods which are given in the SciPy library. So one of them is like the BFGS, so which will execute your code with a limited amount of computer memory. So you can optimize your code by this way. So we have a math function like the minimize function, minimize your equation and the method which you want to use like the BFGG. So if you execute this function, okay, so it is an optimizing code. See, these are the linear algebra, how to execute a linear algebra function with the SciPy. So let's suppose we have two equations, 7x plus 2y equal to 8 and 4x plus 5y equal to 10. This is my two methods, and I want to resolve this function by using the SciPy. So we have library SciPy import linear algebra, lin-alg. The full form lin-alg is the linear algebra. NumPy, we do not require the use the NumPy as an NP, because whenever we are using the SciPy, NumPy is automatically added. So again, we are creating two array, np.array 7, 2, 4, 5, and 8, 10. Okay, these are the values 7, 7x, 2y, 4x, 5y, and the second is the 8 and the 10. So we have method linear algebra.solve a comma b print a. So by using this equation, you can find the answer of the 7x plus 2y and 4x plus the 5y. So if again we want to, if you want to inverse our mathematics, our 2D array, so we have linear algebra lin-l dot inv. This is my method. By using this method, we can inverse our matrix. So what is the meaning of the inversing here? Again, we have to go for the mathematics side. So it's a determinant of the matrix. Like again, we have array like 9, 6, 4, 5, and by using the det method, we can find the determinant of our matrix here. If we have some big equation like x plus 3y plus 10z equal to 10, 2x plus 12y plus 7z equal to 18, and so on. This big equation can be solved by the SciPy library. Just check this code. We are writing A equals to np dot array 1, 3, 10, 2, 12, 7, 5, 8, 8. These are the three libraries here. So we can write here linear algebra dot solve A comma B. So this is the way we can solve it here. There are the many other methods which are part of this SciPy library. Okay. Again, there is one more thing, that's a data file data format. One is the CSR and the CCR. These are the file format methods. We can create the sparse matrices. So what's the meaning of sparse matrices? See, let's suppose if you are working with a categorical data on a transactional data set. So many times we face a issue that a number of zeros values are the more than the number of non-zero values. So this kind of arrangement of values called by the sparse matrix. So let's suppose we have a data set where false values, number of the false values are the more than number of the true values. So this kind of arrangement of values or the matrix is called by the sparse matrix. The problem with the sparse matrix is that we have to deal with the false values. So let's suppose we have two matrices 3 by 3, A matrix and the B matrix. In 3 by 3 matrix, there are the total 9 values are there. Out of 9 values, 6 values are false and 3 values are true. Okay, 6 values are false and 3 values are true. If you want to multiply A into A matrix, it means it will take a lots of time to multiply false with false values. So it will take time. So this kind of arrangement of matrix called by the sparse matrix, we need to remove or we need to convert this sparse matrix into dense matrix so that it will optimize our code. Okay, so we can use this kind of arrangement by methods. Okay, so by using this dense method, we can change our method, so we can change our method from sparse to dense. So let's compare the speed. So by comparing this CSR method, CSR, what is CSR actually? Okay, so CSR is a method. It's a compressed express row format. And second is a CSC, compressed express sparse column methods. So these are the two methods by using you can convert or you can execute your code from sparse to dense. I will share again this PPT, this sheet with you, so you can understand why we are using CSR and CSV. So by using this graph, you can understand in which case we have to go for the CSR and in which cases we have to go for the CCC. So these two methods, we say that these two sheets are sharing the optimization code for CSR and the CSSC. So this is all about me, all from my side. Yes, friends, any question?
The participants are now allowed to just put up some queries, if any. Kindly raise your hands. I'll unmute yourself one by one and take up. Sir will take up the queries.
Sir, you have explained about the CSR and the another one is CSS. So can you just explain the differentiate between these when we should use these two methods clearly?
Yes, ma'am. Ma'am, I'm sharing my screen here. Wait. See. Okay, see this matrix here. We have one matrix here, CSR format. Okay. So if there are the many zero values, okay, and if we want to convert this compressed row for sparse format, that means you want to remove these rows from your means number of rows are having the many zeros here. So we should go for the CSR. If we want to remove zeros from the column, then we have to go for the CSC method. Yeah, any other, ma'am?
Okay, thank you, sir.
Okay, thank you, Anuradha, ma'am. Thank you, Matt, sir, and thank you all other participants.
Dear participant, if you have any question, please put in the chat box, or either you can unmute your mic. If you have any query, please.
Hello, sir.
Yeah, Ashish, sir, please.
Yeah, actually, it was a very nice session. So, actually, you have told all the basics of the things of NumPy and SciPy. Like, I just wanted to know, like, if you can just let us know the kind of like the application part of little bit of like how, because we all are learning machine learning, but how we are going to use this in the application. So it will be kind of like bit helpful if you can give some insight on it.
Yeah, definitely, Ashish, sir. So again, I mentioned you that at the beginning of the session, I told that what is the advantage to use the NumPy array over the list. So we created a program in which we mentioned that speed or the execution time which is taken by the NumPy is the quite smaller compared to the list. So anytime whenever we have large large big data set, especially in machine learning, so each and every time, what we say the most of the time, I experienced that we use the NumPy array instead of the list. So if you're creating any model which has a big number of values, so we always go for the NumPy array or the SciPy array, because list is the very taking the very big time compared to NumPy array.
No, like I just wanted to know, like we are using kind of several machine learning algorithms. So kind of like support vector machine, neural network, and there are lot of models are there. So I just wanted to know uh, like these NumPy and SciPy and the mathematical terms, how we can apply in case of these algorithms, and what are the like, just I wanted to know like logic behind the model and the use of these techniques.
Actually, sir, see, first of all, which algorithm do you want to use? It depends on the problem statement that you want to solve based on the data set, what data set you have. Okay.
Yeah.
Second, so according to that, you can choose your proper algorithm. For example, if you want to go for the classification, so we have the number of the classification method available. So depends on your data set and depends on your the problem statement that you want to achieve. Secondly, that's a where to use the NumPy array and the SciPy array. So see, in my one code, I mentioned that's optimizing our code. So let's suppose that's if you want to if you want to execute a big code which is not possible to execute on the Google Colab or on your own machine, and this is not also possible for you due to some any reason. If this is not possible to execute that code on your Azure on the AWS due to short memory of your system, so we want to optimize our code, so we have to go for the SciPy library. We have many methods there, like where the BFDG methods are there, which can execute your code on the short memory. So this is my personal experience. If there was approximately 10,000 rows were there, and 21 columns were in my data set, and I was executing that, so I applied the concept of this BFDG. If I was not using that, my system was crashed, and this was not running on the Google Colab. But by using the SciPy on the Google Colab, my code was completely executing. So this is the way we can work on this library.
Thank you.
Veronica ma'am, your mic is on. Do you wish to put up any question, any queries from your side?
Okay, Anuradha ma'am, over from my side.
Okay, fine, sir. Dear participants, I hope the session which we had was really a very valuable session, and you got an insight of the different scientific libraries of I would present a certificate of being for acting as a keynote speaker for the session of today, and I would thank him to provide such a valuable information to all the participants. Okay, fine. Thank you.
Thank you all. Thank you, Anuradha ma'am.
Thanks for such an appreciation. Messages from for the keynote speaker for having such a valuable knowledge and providing us with such a valuable information. May, sir?
Yes, ma'am. Thank you, dear professor, for your valuable and informative session. And I hope that all the participants really enjoy the session. And many basic informations and all the questions from the participant has been discussed. Dear participant, there is information for all of you. We are sharing all the content through your email address, and the assignments are being uploaded in your account. So I request to all the participants, please submit your assignment timely. And today's assignment has been published. You can submit by tomorrow as soon as possible. Okay. And the participants who are not registered at the platform, we are sending email and containing the assignment as well as feedback form. So all of you are requested to submit in well time. And lastly, if you have any kind of problem to joining the session or obtaining the content from our side which we are uploading for you, please you can approach me, and WhatsApp number I have already shared with you. And once again, I am announced my WhatsApp number for international participant and Indian participant. Even call me at the same number. My WhatsApp number is plus 91 97 80 92 0053. So if you have any kind of challenge, please don't hesitate. You can contact me anytime, and our team will surely provide you the solution or will sort out the problem. Once again, thank you to all. And now the session is over. Thank you, dear professor, once again, and all the audience to show your interest in this wonderful faculty development program. Thank you to all.
Thank you all. See you soon tomorrow.